Hello, welcome. Today we are going to discuss about Plant 3D. The Plant 3D software is basically a piping design and fabrication drawing software. So here we will see how we can create a project. We can create specification and catalog. So as you can see, we started with we can create a new project from scratches. We just need to give another a folder. We don't need to copy any existing project right now. We are going to start with scratches. We are going to select the units. This is our PNID, which template we want to use. Later on, we will see which PNID template we are going to use. Um, then we have Ortho and Isometric folders. We can change, but we don't need to change. We need to keep it as per the standard places. Once this project is created, we can see that here will this project will appear. So right now this project has come with standard structure with all the built-in piping specifications, uh, and we can use these specifications, but in order to comply with our project specification, we need to build our new specifications. So we will see how we can create the new specifications. uh, this all the data is stored in the content folder, which is available in C drive, and in our case mostly we will be dealing with CPEC as me folder. We will be placing all our catalogs, specifications in this folder. So now we need to start building our specification. I have made the shortcuts, for the specification editor and the AutoCAD Plant 3D software. So this is, specific editor. You can see that right now I don't have any specification. So first we need to create new specification. I will just name it 1CS1P, which is standard specification for Saudi Aramco. We can create any specification of any client, but here I just try to make this specification, and we can give some details like this is 150 class raise phase, or we can define any other detail here, and we don't need to link any existing catalog because we will be creating new catalogs for this specification, uh, as we don't want to disturb the standard catalogs. So once specification is created, we need to create two catalogs. So we will go to the catalogs. Okay, here this is our catalog folder. So we need to create uh, this is catalog. We'll start from existing catalog, which is our reference catalog. It's stored in C drive content folder, cpack as me. Okay. Okay, this is you don't need to follow this common one. The second one, this does not have actually the our required one. So second folder, uh, we will go to the second folder, not this folder. So okay, so this, yeah, this cpack as me folder we need to click, and now here you can see we have a standard catalog for valves and fittings. So first we'll select the fitting one. Now our nomenclature is like we are creating a specification, so we rename this as our specification dash the same name, and then at the end there is a copy, so we will delete this word copy, and we will create. So now this catalog is only linked with this specification. So if we change anything in the catalog, it will only affect this specification and not the other specifications. Okay. So now let's see. We'll create another catalog, which is the valve catalog in similar fashion. So just like pipe and fitting catalog, we will create the valve catalog. We'll rename it to our specification so we can recall it later on. Now, okay, now once we have created the catalogs, we can start building our specification. These catalogs you can see are stored with in the same folder. Uh, if you see here, okay. So these are linked only with our specification, and here we can see these two catalogs are linked with the specification. Now we need to now update these catalogs to suit our specification requirement. For example, in this case, we have one and a half up to 1.5 inch pipe extra strong, and then 2 inch pipe is also extra strong. So we will see how we can build these our catalogs. We can change to our specification. So we'll just use this filtration to find the suitable components uh, so that we can start changing them. So we'll find the pipe seamless, and we have to select schedule. So we try to find the extra strong. Extra strong schedule is not available. So we will try to find the 80. Yes, the 80 is available. The same 80 we can convert to extra strong if we want, or we can keep it as 80. And also, you should know that for large sizes, this schedule 80 is not extra strong. So be careful because maybe the weight is different. It will not affect your modeling, but it will affect your center of gravity if you want to create, and if you want to create the weight later on. So be careful to update the weights as per the requirement. So once you selected the right component, then you can start changing it. So right now we change the schedule. So we have to again find the schedule here. Okay, we'll put extra strong, and here you can see our required component is available. Okay, let's yeah. So here this required component is available. Now this is okay, but if you see the long description, which is not going to be right, so we need to change. Also, you can see the sizes which are not applicable. You can either remove the size here, or better leave them, and later on while you develop the specification, you can exclude the size from there as well. If you remove from here, they're permanently removed. So better, I will not advise to remove, but yes, you can, as a matter of fact, you can remove. So let's now change this long description. The long description should contain the material, the schedule, etc. So which we are going to add. This long description will appear on our BM as well as on the isometric drawing. So we need to be very careful and consistent while giving this long description. So other than this, it's not nothing very important. We can just leave as it is, and then we'll just save it, and we will add this to our specification. Okay, this now specification. You should see you have first component. Now, if you are going to add another one, okay. So first we need to see how we can update. See, we changed, but we did not save. So we saved now, and we need to update from specification from catalogs so that it gets affected. Now see the description has changed. It includes the grade B. So that's done. Here we will remove the pipe sizes which are not extra strong. So we will select all these sizes one by one, and we will just exclude them so that we cannot see them. Okay, so this is done. So now let's move to the second component. So again, we will choose the same pipe which we have selected, uh, or we can standard. We have standard pipe as well. Uh, okay, we can just make a duplicate, but be careful when you are doing this. You need to update the weight data. That you can easily do later on. So right now we are going to change the schedule. Okay. So once we have changed, we need to save it, save to the catalog, and then again we need to find the same component in catalog and just add to the specification. So we will keep doing this for each component. This is one-time exercise. Once you have the database built for one project, you can just copy the same database to another one and just change the required specification. Typically, there are not many changes, so you can just quickly do this type of changes. However, one should know how to create the specification, how to add the specification, how to change the long description, how to change the components. So this is all we have to done, and I have demonstrated. Similarly, now to the pipe, we are going to add the other components like elbows, then flanges, and we can even add right now and change their description later on. It's up to you. We'll quickly go through this. So I have just speed up the video to save the time. We just quickly save few items like elbows, flanges, and demonstrate specification. Later on, I will pull my already created specification, and then we'll start using it. So you can, once you have done the changes, you can change the weights. Primarily, we need to change the weights of the components if the schedules are not available. Otherwise, thickness is not going to affect, as it's not calculating weight based on the density. So we'll just keep adding these components one by one, and we need to select the sizes, which sizes are applicable and which are not applicable. This way we can create the whole specification. So as you see, I'm just selecting what are applicable and what are not applicable sizes. Okay, this one size was not there. So now see, it's all resolved. Similarly, we will go and add the flanges and the other components. See, there are so many components, so you just need to select the right component and then just do your changes. For example, here schedule is not given, so I will mention schedule as it's required. I will also update the description so as it should match my requirement. And as I said, you can change this all details later on as well. And once you build the database, you don't need to do everything from scratches. You can copy the specification from one project to other project, do some small minor changes, and just use it. So one time you just spend the time and create the specification carefully, because they are going to be with you for a long time, and they will be affecting your output. For example, if you mention the wrong description, it will come on the BUM, and ultimately it will be reflected on the drawings. And every time you'll have to do the manual changes. So better just prepare specification correctly. The most important thing is the weight of the components, because it is going to affect your center of gravity. So just take care of weight, so that you don't suffer later once you want to give the center of gravity. uh, so that's this is uh, from the process of the specification and catalog creation. So we are almost done with it. We have added few components. Now we will just build some sample file. We just created one folder and created a file to build these piping models. As we select our specification, you can see the components we created are now available, and we can start using these components. Okay, so this is my first component I am just choosing. If you want to shift the direction of the flange, just click P and enter, so that your working plane changes its direction. So for example, here you want to change the give the elevation, so give the elevation something like 500 5000, and it will change the elevation. And you also can um, basically move the components from one point to other point. So these all we are using these all components. Okay, yes, now once we actually added the specification, now we need to update the specification right from the project, not from the C drive, because in fact we should delete it from the C drive once it is there. And this is where you can build the like your branch table. Right now we don't have the branch table, but later on you can build the branch table. So we will see this subject of building the branch table later on. So right now I have imported my specification, which I already built. This is the same specification, but I have already created to save the time. You can see all the components I have created, and now we'll start using these components and build a pipe system. So let's start using it. So we will start with the section of the specification, which is our 1CS1P right now. Okay, and then select the size of the pipe. We have to create a line number. Either we can take it from the P90 if it is linked, but if not, it's not linked in this case, we will just give it manually. So this is we'll give the first component coordinates. If we know, we can give. If we don't know, we can just start building and later on just give the move command to move to the accurate location. So I just gave a dummy number. Later on I will move it. So see now direction, you can see it has direction everywhere. We'll start now adding the flange. Okay, this is my flange. Now if you want to change the direction of the uh, flange, like face or end, so just click control, so you can uh, basically change the direction. Let's add some more components. So for example, I have this instrument I want to add. I don't know what is the size of the instrument, so I will just first add this instrument, go to its property and see the size. So it is 1 inch threaded connection. So I need to add a threadolet. So I will just select the threadolet, and I need to give the location of the threadolet. So I can see from the face I give value, and I will change the size 4 into 1 inch threaded connection. Once it is given, then now I can select. If you see there is a water drop symbol, this is mean it's it's not properly connected. But as we connect the instrument, now it is properly connected. So we can add more components. So we add a valve. We can change the direction of the lever. Also we can rotate the valve. And we will add another flange, another valve, and at this time we are adding globe valve. So we'll just keep adding the components one by one as per the PNID, and we'll create one line. So we will just create a branch. This branch is already with the branch table, so that's why it's a T is coming. And we can rotate the T direction. We can rotate, add. There was some error because I mistakenly my slope was on while building the header, so that's why it's gave the error. So we can add instruments, we can add valves, inline atoms, we can create and connection. So this is how my first piping spool or piping line is completed. So let's create an isometric and see how it is done. Later on, we will see how can we I mean configure our isometric style. But let's use whatever is available. So now you can see this isometric is done and it has proper description. We want to see the rest of the two drawings, so they are not opening from here, so we will open them from the backend. So let's go to the project folder, and these files are there. So yeah, there's some error still with threadlet. We need to fix it later on, and we can see these drawings. Now the isometric drawings are created. We need to create an ortho drawing. So before ortho drawing, we will add some structure to give it a skid shape. So we will just define the dimension. We'll start giving the profile. Uh, I don't know why is what happened, but this line is not giving the structure. So we'll just add one by one manually. We'll select the profile which we want to use, and we will just start using from one end to another end. You see that this is giving us only a symbol, so we need to create to 3D. So we'll just have to convert this to full 3D or basic 3D. So from here we can change it. Once we change this one, we can see the profile shape. So we keep adding all the profiles as per our requirement, so that we can move them, we can align them, we can copy them from one to another one. So like this one is added, we'll just demonstrate how we can copy. So right at the center of this we added one beam, and now we will see how we can cut these beams. Later on we will also let you know how you can connect the advanced steel uh, model to this piping, so that you don't need to perform all these cuts and these operations here. So you see the cutting process is done. Now let's add one pipe support. So we'll choose one appropriate pipe support. In this case we choose this one, which is kind of T. So we'll just give this location, and we'll just move the base to this one. We can also increase the length, but we are just moving it. If this is just a training session, not the actual one. We'll give the pipe support tag and the description of the pipe support. And now we will create an ortho. So we need to go to ortho. Here we need to create a folder first, and inside the folder we need to create the drawing, the blank drawing. As soon as we create it, here is the drawing. We can change its template later on. So we will just create now our first ortho. So we need to select this line, and this ortho we box is there. Whatever is in the box, it will show on our drawing. So let's just visualize on the paper how it will look. So we can change the scale, bigger, smaller, and see how it will fit on the pipe on the paper. Once it is done, we just need to click on OK, and we can see that now this is done. But it's coming with the matching lines, northern and eastern coordinate. If we'll see how to remove these coordinates. We just copied it to another view, which is the isometric view. So we can um, change. Okay, yeah, here from match line you need to turn it off, and you just make it okay. So this is how we do the ortho drawings in the Plant 3D. So today we have covered how we can create a new project, how we can create catalogs, how we can create specifications, and then how we can create piping components, start using it. So in the later sessions, we will see how we can create the user shapes, as well as we can review the process of creating the equipments, the standard equipments like tanks, vessels, and customize equipments, uh, customized nozzles. So we will cover all those in some other video. For that, you have to follow our page, our YouTube channel. You need to subscribe so that you can receive the notification for our next video. And this. I hope this helps you to learn this brilliant software, uh, and enhance your skill. So I'll show you how you can turn off the layers. To, for example, here I just want to show the structure, and I want to hide the piping. So we'll just I have to go to the X reference of this drawing, ortho drawing, and then just freeze the layers. Once we freeze all these layers, we can easily just keep the structure and hide all the piping, so that you can uh, just see the, I mean, give the drawing of the structure only, or any other component you want to just show the detail, you can show it. So here you just need to turn off everything, and just click OK, and you will see that you just have the structure. So this is how you can do it.